Once we are done with sequence acquisition, multiple sequence alignment in phylogenetic analysis, the third step is model of substitution. What is model of substitution? It is basically a model which changes one sequence of characters into another sequence of characters. So here I will explain it with the help of an example. Suppose we have 5 different characters 0, 0, 1, 0, where 0 shows that a species have no feathers. And the other 0 is for it doesn't lay eggs. Then 1 we have furs, 1 for warm-blooded, and 0 for no breathing underwater. So suppose we have species which has these 5 different characteristics which are shown by these 5 sequence 0, 0, 1, 0. And if I want to convert this in another sequence 1, 1, 0, 1, 0, where 1 of course means that it has feathers, then 1 for lays eggs, 0 does not have fur, and so on. What is the way how we can say that this thing will change into the other? So if I focus on this thing, what we are basically doing is we have sequence of characters, and then we will have to change each sequence character wise. For example, first 0 will be changing into one of the other sequence. So for that purpose we have different substitution models. So what are those models, or what are, number one, what is usefulness of those things? If we have such models, then they will be useful when we are designing or developing phylogenetic trees where we want to infer relationship between different species. Similarly, we can have these models which can be used for testing our simulated data. Simulated data, because during evolution we don't have details of all the species. What we do, we say that for certain species we generate some random data which is a simulated data, which is not real data. So there are three types of substitution models. Number one model is neutral model, in which what happens, there is no concept of positive or negative mutation. It is only always neutral, and we say that it does not operate on substitutions, and they are always unconstrained data models or models of substitution. The other one is independent models. Independent models means that substitution in one sequence will not affect substitution in the other, so they will not be related, or there will not affect changes in from one sequence into the other sequence. Finally, we have finite state models. In finite state models, whenever we want to substitute characters, we have finite number of states. Finite or number of states means more than one states. So we don't know at one time which state will be occurring. So a character can take more than 2 states with the passage of time. So for this one we have Jukes-Cantor model. What is Jukes-Cantor model? We say that, for example, we have 4 sequences, and what will happen for each sequence, we have 4 bases for a DNA sequence, which are A, C, T, and G. So what we say, that if we say that one sequence can be converted into the remaining 3 characters, so we say that one character is taken by a parameter called alpha. So what will happen, this alpha, it can have uh, its chances of substitution via 3A. So 1A can be converted into 3A different places, which is shown by alpha. So what is the usefulness of this Jukes-Cantor model? Usefulness is to find the number of substitutions per site, which was given by K, as shown in some previous module, where we said that K is equal to number of substitutions per site when multiple substitutions are available.